as well as ACL. These institutions are running classes for JEE main and NEET successfully. So coming session, JEE main session, for all the students, all the best. And the candidate session starting from 27. With these few words, I am going to start a topic called work energy power. Work energy and power. Okay, students, I will give some basics. After we discuss each problem given in this list here. Given this list here.
First question.
Clear? Okay, students, let us define work. This is a very important chapter, mechanics, work. This work definition and energy definition, very important work. Work. What is the physical meaning of work? We generally use the language we are doing some homework, mental work, all these works we are doing. But by doing that work also you are spending some energy. Muscular, sometimes you are lifting, muscular energy you are spending. All these things. Blood, we are using some mind. Then you are using some energy, muscular energy. But physical meaning of work is said to be done by force. What is work? When it produces displacement in the direction of the force or in the component of the force. The direction of the component of the force. So work is said to be done. Work is said to be done. Work is said to be done by the force. By the force. Now I am telling constant force. By the force, let us take first initially constant force we are taking. Constant force means constant acceleration. Constant force, if it produces displacement. If it produces displacement, in the direction of the force. The direction of force or component of force. So that is there. So I am drawing a diagram here. Students, there is a block here. Let us say block is resting on a smooth surface. I am applying a force like this at an angle theta. Body is moving through a displacement. Yes. But F is in this direction. F is resolved component. And resolved component is nothing but equal to F cos theta. Displacement is in horizontal direction. F is in this direction. But another component is balanced by weight here. F sin theta, that is normal reaction, that is balanced by weight. There is no, let us assume that body is moving in horizontal direction only. Then work done is defined. What is the definition of work here? Work is the product of component of the force and displacement in the direction of the component of force. Work done is the product of component of force and displacement in the direction of the component of the force. W is equal to Fs cos theta. This is the formula. W equal to Fs cos theta. Where F is force, S is displacement. So F is what? Ma. Constant force means F is also constant. Then you can apply equations of motion also. That you learned in motion a straight line. V is equal to U plus AD to calculate acceleration and all that. S is equal to U plus of AD square. So previous chapters are necessary sometimes. But W is equal to Fs cos theta. This is important. What is theta? Angle between force and displacement. Theta varies. For example, theta is 0 degrees. Or theta less than 90 degrees. Work done is positive. Work done by the force is positive. Work done by the force is positive. Work done by the force is positive and theta is 0 degrees. Cos 0 is what? You get that. For example, if theta is equal to 180 degrees or theta is greater than 90, you can say theta is greater than 90 also. Generally theta 180 will take mathematically for both MPG and BPG student JEE main and NEET. W is equal to Fs cos 180. Cos 180 means minus 1. This is negative work. This is negative work. This is negative work. Work done is negative here. Work done is negative here. So zero work is also there. That is very, very important. Zero work. When you have zero work, that is a person is waiting in a bus stop for 5 minutes. He is not moving. Displacement is zero. Definitely work done is zero. When zero work is there, zero work. Very, very important one. Zero work. When you get zero work, then displacement is zero. Even force is applied also. Let us say I am pushing the wall, failing to displace the wall. That is standard example. Displacement is zero. Even though you are applying force and pressure, displacement is zero. Definitely zero work is there. But sometimes force will not be zero, displacement won't be zero. Then theta 90 degrees. One of the cases is nothing but what? Theta 90 degrees. For theta 90 degrees, for example, we are taking theta 90 degrees for theta 90 degrees. Theta 90 degrees. So what will happen theta 90 degrees? W is equal to Fs cos 90. Cos 90 is 0. Then work done is 0. What is the example for this? A person is walking. So I am just, this problems will discuss later. So theory element. This theory if you want you can see later also. I want to know this. More like that. More. Right. Next, what is the example? One person, sorry students, on break. Person is walking along the road. Person or porter carrying load in the head. So mg is weight as well as the weight of the anything is given is walking along the road, for example. The person is walking along the road. So it is producing displacement like this. But F is equal to mg. Work done by gravitational force. What is work done by gravitational force? Work done by gravitational force is nothing but equal to mg into cos 90. Therefore, work done by gravity is 0 in this case. So 0 work. When theta is 90 degrees, work done will be 0. So this is the now. So in example positive work and negative work, we have some examples also. Further, basically from standard books like SC Verma, they will start work done is equal to change in kinetic energy. So work energy theory. So kinetic energy relation. What is kinetic energy? The energy is capacity to do work. Work and energy are not the same. Any machine can perform some work. So capacity to do work is called energy. So energy and work are one and the same. So one more information before going to energy. Work is a scalar. Work is a scalar. SI unit is, what is SI unit? SI unit is joule. Joule. SI unit of work. You are learning from school class onwards. Joule. Newton meter also you can write. Some books will give Newton meter also. Joule, SI unit. CGS unit is that. SI unit is joule. Right. But work done is dot product. So work done is scalar. Work done is F bar dot S bar. Work done is nothing but F bar dot S bar. Dot product. Scalar product or dot product. F vector can be given ijk notation. Displacement vector can be given IJK notation. Then we have to do the problem M dot S. So when you use Fs cos theta, when force value is given, displacement value is given, theta angle is given, then you will use W is equal to Fs cos theta. When they are given vector notation, F bar in either I or IJK notation or IJ notation, displacement also in IJK notation, then we use dot product like this. These are category of problems. So then next thing is energy. I want to tell you about energy. Energy is mainly first energy when we are discussing when body is in motion, momentum will be there, kinetic energy will be there. Earlier chapter Newton's law we learned body is in motion will have momentum. Body is at rest, momentum is zero. Similarly, kinetic energy also, body is in motion will have kinetic energy. The kinetic energy can be derived by vector only. Kinetic energy KE, that is given by the formula half mv square. M is mass, V is speed. V square can be written V bar dot V bar also. If at all V is given, I take relation. Kinetic energy mv square. How this formula will come? IP will learn in first year derivation. Basic derivation is what? W is equal to F into S. F into S. F can be given as MAS. So J. So if you write actually what done, this is derived from basically from what done is equal to F into S only. Theta is 0 degrees. Let us assume theta is 0 degrees. MAS. A can be written as V square minus U square by 2S into S. V square minus U square by 2S into S. S can be cancelled. If we assume U is equal to 0, we assume U is equal to 0, it will become half of this square. So anything can be done, any energy can be derived this way. And so the standard books will start generally first kinetic energy. Then work energy theorem. This is very, very important. Most of the problems easily can be done by work energy theorem. What is the work energy theorem? So work energy theorem can be like this. So it's work energy theorem. Work energy theorem. Work energy theorem. The important theorem. Work energy theorem. Work done by all the forces. Work done by all the forces. Work done by all the forces. All the forces. That is, all the forces means what? External or internal. External or internal. External or internal. Work done by all the forces, external or internal, is equal to change in kinetic energy. Is equal to change in kinetic energy. Change in kinetic energy. This is important theorem. So you need not go to kinematics equations in this chapter. You can learn many problems. Work done equal to F into S. That is nothing but equal to half mv square minus half mv square. I am writing the formula here. Work done is nothing but equal to F into S. So theta 0 is F2. So half mv square minus half mv square. Or you can write final kinetic energy. This is called final kinetic energy minus initial kinetic energy. Change in kinetic energy. So this formula will be very much useful to find out velocity. Let us say braking force is there. Some velocity is 0. You can easily relate S and kinetic energy. Force is constant. So that is the work energy theorem. External force, internal force. Sometimes non-conservative forces also will be there. So that it will be later. Non-conservative force friction is also there. Then total mechanical energy will not remain constant. So there is loss of energy will be there. External forces are there. So then first we will see what is the constant force is like this. What done by variable force means how to do. What done by variable force means how to do. I am telling you. What done by variable force. Variable force means force varies with distance. What done by variable force. Work done by variable force. What is meant by variable force? Force varies with distance. Force varies with distance. So let us say there is a graph here. F versus S. F versus this. S. F versus S. This graph is like this. Irregular graph. You have to find out area under this graph. So how to find? So work done, you take small element here, ds element. So dw is nothing but equal to f is a function of distance they give you. dw is nothing but fds. Small amount of work done for small element nothing but equal to ds. This element is nothing but ds. You divide the element into small strips. dw equal to fds. Total work done, how to find out? Area means integration. Area means what? Integration. Integral fds. Integral fds or f dot dr. So we take the limit, lower limit and upper limit for different integration. W is to integral fds, force is a function of x. This is variable force. In case of variable force, you can't use equations of motion, students. Children, f is equal to ma. When you are using equations of motion, when a is constant, then only we can use equations of motion like p is equal to u plus ad, etc. S is equal to u plus half ad square, b square minus u square is 2as. When variable force, what done we have to integration. So area under force displaced sometimes the graph may be constant, force also you can use. Area under the force displacement graph use work done. Whether the graph is curved or the graph is straight line parallel to x-axis, then also area under force displacement graph gives work done. Area under force displacement graph gives work done. That is important one. So next thing is learning work energy theorem, and this one I will tell you what is meant by potential energy. I tell you potential energy now. I tell you about potential energy. Conservative forces. There is conservative, non-conservative forces. Yes, no, I told. Conservative forces. What are conservative forces? Work done by conservative forces. Conservative. There are two types of forces. Conservative force. Conservative forces. What are the examples for conservative force? Gravitational force. Gravitational force. mg. Gravitational force. Right. Then electric force. Then second year. Electric force. Etc. Like this. These are conservative. What is conservative force? Work done in the absence of frictional forces, let us say freely falling body is there. There is no air friction. Work done by internal force like gravitational force. So gravitational force that produces then potential energy. Work done by conservative force. Work done by total path in a closed path will be zero. You will have to intermediate work done by in a closed path. If it is zero, then it is called conservative force. It doesn't depend on the path. It depends on initial point and final point. Conservative forces, non-conservative forces cannot produce potential energy. Conservative forces, it produces potential energy. It produces potential energy. It produces potential energy. So gravitational potential energy, I am giving a body lying on the earth. So the body lying on the earth, height is zero, potential energy will be zero. A body is taken to a height h. So potential energy will be there here at this point. Gravitational potential energy. Gravitational potential energy. PE means potential energy given by letter U. So U is nothing but mgh. H is very less than radius of the earth. So in gravitation we will take distances equal to comparable radius of the earth, but in this chapter is not necessary because h is very less than radius of the earth. H is very less than radius of the earth. So in that case, U is nothing but equal to mgh. H is the height. When height is zero, potential energy will be zero. When it is on the ground, let's say this is on the ground, potential energy will be zero. Then the point B, potential energy will be there. But what is meant by this? So potential energy is negative rate of work done. Potential energy is negative rate of work done. But remember, U is nothing but equal to minus W. U is nothing but equal to minus W. This is regarding gravitational potential energy. Now spring energy is there. That is variable force. Spring energy. Telling about spring energy. Spring energy. Spring is variable force. Spring force is there. What is spring force? Students, spring force. Spring, you know. This is the spring. Nothing like the spring. If you want to extend the spring like this, this is nothing but extension. Spring is having some material like steel or brass. It is having some constant. Spring constant K is there. K is called spring constant. F is equal to minus Kx. Here, force is proportional to x. Force is proportional to minus x. Restoring force. Proportional to minus x. This is elastic nature. Spring force is a variable force. This is a variable force. This is a variable force. We will apply integration. Any variable force proportional to x or x square, we will apply integration. So I told you integration, when you apply dw is nothing but equal to w is nothing but equal to minus kx dx, f dx, kx dx. So by doing integration of x square by 2. So the formula by which students also integral x to the power of n dx is equal to x to the power of n plus 1 by n plus 1. That formula is valid for all the powers except n is equal to minus 1. N is equal to minus 1 is not valid for all the powers. That formula is valid integral x to the power of n dx, nothing but x to the power of n plus 1 by n plus 1. In that formula x square is 1. We are going to get work done is nothing but equal to minus kx square by 2. But potential energy, negative rate of work done, what is potential energy in case of spring? Half kx square. Potential energy in case of U is denominated potential energy students. This is conservative forces produces potential energy concept here. So now what I am telling you is work done by all the internal forces. Gravitational force is the internal force for vertically pointed body or freely falling body. This produces potential energy. Then in the process kinetic energy is also there. So total mechanical energy will remain constant in the absence of external forces. In the absence of external forces. In the absence of external forces, total mechanical energy will remain constant. In the absence of external forces, in the absence of external forces, in the absence of external forces, total mechanical energy remains constant. This is very important theorem. This will produce so many problems easily. Total mechanical energy remains constant. All complex examinations. So wherever it is there potential energy is there, kinetic energy is there. Mainly potential energy means maximum extent it will come whenever falling the vertically pointed gravitation potential energy only will come. Spring energy is separate, but elastic energy. So here, what is meant? How to do this? Total energy will remain constant. Total energy, let us say E. This is total energy. Total energy, total mechanical energy. This is called what? Total. External force is total mechanical energy. This is mechanical energy means what? Potential energy and kinetic energy. Potential energy is energy produced by virtue of position or changing state. Water stored in a dam will have potential energy. Bent bow has got potential energy. Kinetic energy, no. Kinetic energy, for potential energy, body need not be in motion. For kinetic energy, body should be in motion. In motion only kinetic energy is there. Because kinetic energy basic formula is half mv square. Okay. Potential energy in any position, at rest, water stored in a dam is at rest, but it has got potential energy to its state like that. That is energy produced by virtue of position that we learned in school classes. By energy produced by virtue of motion is kinetic energy. Total energy is nothing but equal to U plus K. This should remain constant in the absence of external forces. So U plus K is remaining constant. This is easily when we apply a situation. U1 plus K1 should be equal to U in any situation. U1 plus K1 should be equal to U2 plus K. This is for conservation of mechanical energy is valid in the absence of external forces. But if external force is there, what will happen? Kinetic energy may change or potential energy may also change here. That's why in our situation generally we don't take external forces. In the internal forces we take that is nothing but U1 plus K1 should be equal to U2 plus K2. Then total mechanical energy will remain constant. Okay. The right students will go to the numericals based on this work basically is what? So I am telling you because you are going to face complex exam, your JEE exam shortly. So yesterday, Director of SPARK, ECL from the branch here yesterday he told about tips about the JEE. Today of course I am telling lesson, but how work can be used in different situations. 2 minutes I speak and go to the problems. How generally, so you know work and energy, what they use. For example, potential energy. Now we are telling what? MGH in this chapter. But gravitation chapter, what do you tell? So you know energy. I am giving some work or energy, how important. Today I am limiting to only work and energy, but not to power. But not to power. Okay, students? Not to power. Okay? So here, so like generally, for example, in situations like first year, you get gravitational potential energy. What is the formula for gravitational potential energy? This is nothing but gravitational potential energy. Gravitational potential energy, how will you give? U is equal to minus G, capital M, small m, by small r. What is small r? Distance from center of the earth. It can be r plus h. R, between two bodies, you want to know m1 and m2 are separated by distance r. What is the potential energy? Minus G1 m1 m2 by r. Why minus is there? Attraction. Minus G m1 m2 by r. Like this. This is gravitational potential energy. Similarly, in electrostatics, charges and fields, we get a potential energy, electric potential energy. What is electric potential energy? For basics I am telling this one only. Electric potential energy. How will you calculate electric potential energy? By work done only. Work done is charge into potential. Work done is equal to charge into potential. Electric potential energy. What is electric potential energy? Electric potential energy U is given by a formula, then constant will change. Here what is G? Gravitational constant. Capital G is called gravitational constant. Capital M is the mass of the earth, small m is mass of the body. The second example, M1 and M2 are two bodies in the earth, separated by R. There is gravitational force is there. Potential energy is also there. Now electric potential energy is nothing but equal to 1 by 4 epsilon naught. This is one constant. Q1 is charge. Q1 equal to R unit. Force means what? Coulomb's law, you know, 1 by 4 epsilon naught, Q1 equal to R square unit. That is a vector. But these are all scalars. Today all scalars too. Work done is scalar, energy is scalar. Do not have direction. So energy unit also, joule only. Any energy, gravitational potential energy or any electric potential energy, any unit is there. What is epsilon naught? Permittivity. Q1 is one charge, Q2 is another charge, separated by distance r. So, but you can use this work energy concept in second year also. Work done by the dipole in the rotating the dipole in the electric field, like that. So if you go to that extent, you will be feeling little tougher. But already as far as I have given instructions to you, you read chapters in physics as far as my experience is considered. Modern physics, okay, EG1, you will get 5 to 6 bits, 5 bits you get minimum. In that also, quadratic effect, conservation of energy we learn. Conservation of energy, quadratic equation, we are going to learn. Kinetic energy is nothing but equal to h nu minus work function. So that is all conservation of energy only. So quadratic effect. Similarly, atoms also, we have kinetic energy of the electron, potential energy of the electron, total energy of the electron, will have. So if you carefully see, you can use this concept there also. So modern physics is one of the important chapters. After current electricity also, problems are there, EG, you can be doing like that, etc. You can do. Second year, current electricity, modern physics. First year you can do gravitation, center of mass, all these concepts, there's of gravity, work energy, basic Newton's laws, like that if you see it. So okay, right. So you see that this. Now I am going to do problems. I am going to do problems with these few basics. So kinetic energy, one more formula is there, that is p square by 2a. One more formula is there. Kinetic energy half m square generally. One more formula is in terms of momentum. That typically there some problems are they are asking complex examination. Kinetic energy is also given by p square by 2a. P is momentum. That means mass. So based on all these concepts, we are going to do some numericals today. So this is the theory part. Okay. Right. So first problem. We are taking first problem. We are doing the first problem. Please see the first problem straight given the previous examination. So this is variable force. If you want to do easier than this, I'll give next question. This question is force is a quarter moves to the position 5i minus 2j plus k from its initial position. This is final position, this is initial position. Under the action of the force 5i plus 2k plus 7k. So displacement directly is not given, force vector is given. What is force vector? 5i cap plus 2k cap plus 7k cap. Force is given. Initial position is given. What is initial position? R1 bar, this is called initial position. 2i plus 3j minus 4k. What is the final position? R2 bar, 5i minus 2j, 5i minus 2j, 5i minus 2j plus k. This is final position. This is initial position. Initial position is this. So final minus initial. What is S bar? R2 bar minus R1 bar. I am subtracting. R2 bar minus 5i minus 2i. This is 3i. Minus 2j minus 3j minus 5j. R2 minus R1 minus 2j minus 3j minus 5j plus k minus 4k plus k minus 4. 1 minus of minus 4 plus 5k. 3i minus 5j plus 5k. This is displacement. What is vector? Vector we know F bar dot S bar. So 5i plus 2j plus 7k dot 3i minus 5j plus 5k. Okay students, how to do dot product students? For biplane MPC, there is a formula dot product. I to I, j to j, k to k only multiply. Remaining will become zeros because angle between I and j and k is 0 degrees. Don't go to that analysis. We will learn in mathematics also. So it is easy, but biplane students may not learn. That's why you have to learn some formula. I to I, j to j, k to k you have to multiply. 5 into 3, it's a scalar. 5 into 3, 15. So I got like 1 plus 2 into minus 5. 2 into minus 5, that is minus 10. 2 into minus 5 minus 5 plus 7 into 5, that is nothing but equal to 35. Therefore 15 minus 10 plus 35. 35 plus 15, 50. 50 minus 10, 40. Answer is equal to what? 40 joules. This is given in 2023. Only thing is you know the dot product. Very simple. You know dot product. This is how we are going to do the problem. Okay, students, I am keeping all the problems intact here. Only theory only I rubber off. Right foot. A block of mass 10 kg moving along x-axis under the action of the force F is equal to 5x newtons. This is a variable force here. The force is proportional to displacement. The acceleration is proportional to displacement. Because mass is constant. What time that force is moving the block from x is equal to 2 meters to x is equal to 4 meters. You can't apply directly x is equal to 2, x is equal to 4. Yeah, fx you can't apply like that. Then x is a variable force. But apply, how to apply? W is nothing but integral f dx. Integral, this is called integration symbol. So W is nothing but equal, W is work, integral 5x dx. So 5 constant, you take it out. Integral x dx. What is integral x dx? X square by 2. Integral x dx is nothing but what? X square by 2. I am taking 2 also outside. X square, limits are key. What are the limits? 2 to 4, that is the limits. Last we applied 2 to 4 times. 2 to 4. Vector is nothing but equal. Vector is nothing but equal. 5 by 2. First you apply upper limit. Wherever x is there, 4 you apply. 4 square. 4 square means 16. Then you apply lower limit 2. Upper limit minus lower limit. Upper limit wherever x is there, 4 you apply 4 square. 2 square, that is nothing but 4. This is 12. So you get 5 by 2 into 12. So answer is work done in nothing but how many hours? 30 hours. Without doing integration, you can't directly. This is work done by the variable force. So only thing is you should know bypass and MPC students. The MPC students very well versed in integration, most of the students, but bypass students they have to learn one formula. That formula they have to properly catch that point formula and do it. Integral x dx is nothing but x squared by 2. Integral x cube is nothing but equal to dx is x to the power of 4 by 4 by using the formula. Okay, whenever mathematics comes to students should be very careful here. Right. So next question. So here there is a theory question here. I told you positive work, negative work, all these things, zero work I told you. So identify the correct statements from the following. Identify the correct statement from the following. Sometimes they are giving theory also. See, work done by the man in lifting a bucket out of well by means of rope tied to the bucket is negative. Work done by the man in lifting the bucket out of a well by means of a rope tied to the. So there is a rope here. There is a bucket here. There is a bucket. So you are pulling upward. Tension is tension upward. Displacement is also upward. So he is telling negative one. Both tension and displacement are the same direction. Work done should be positive. That means that is wrong. Work done by the man. He is tension the string. This is the bucket. So tension, you are lifting up. Tension. Work done by tension. Tension is upward. Displacement is upward. Okay, bucket. So that is positive. That's why that is not negative. That is wrong. B. What done by gravitational force lifting a bucket? Same situation. What done by gravitational force? How gravity is acting? Gravity is acting. Simultaneously, tension is acting. Gravity is also acting. So how to do problems actually? Positive, negative work. In same thing it is there. Work done by all the forces is equal to change in kinetic energy or do it. So net force is 0. It is moving with uniform velocity. So such a problem, one more problem is there at that point we will discuss. But in this case, okay, gravity is acting downward, displacement is upward. These are opposite. That's why work done by gravitational force is lifting a bucket out of well by a rope tied to the bucket is negative. Why? Gravity is downward, displacement is upward. So therefore this is negative work. This is positive work. Therefore the first one is wrong, second one is correct. Work done with friction on a body sliding down and inclining down is positive. That is also wrong because frictional force. When body is coming down, theta, frictional force will act. When body is coming down, friction acts upward the motion when it is coming down. So displacement is downward, frictional force is upward. Friction is upward. Therefore, work done by friction is acting upward, displacement downward. Therefore, work done by friction on body sliding down, inclining plane is positive is wrong. This is negative work actually. So that is wrong. See. So D. Work done by applied force in a body moving on a rough water plane with uniform velocity is 0 instead. Work done by the applied force in a body moving on a rough water plane. People will be thinking that it is correct, but it is not correct. It is telling applied force, rough water plane with friction force also will be there. Okay. Work done by the force means force in displacement should be there. That's all. So it did not move with acceleration. So it need not be 0. It is not 0. Work done by applied force and a body moving on a rough water plane with uniform velocity means applied force is equal to frictional force. Applied force is equal to frictional force, but it is moved through a distance. W is equal to mu mgs. Frictional force into displacement. Definitely, work done will be there. Definitely. Then V. Work done by air resistance and oscillating pendulum is negative. Pendulum is oscillating. When pendulum is oscillating, slowly it will stop due to air friction. Due to air friction. Then we have talked about the displacement. Definitely that is negative. Pendulum is this one. When oscillating like this. This oscillating will become slow. Friction force will act in this direction and avoid the displacement. Air friction. Air friction will act. That's why this is negative. Therefore answer is B and D. Even though this is a theoretical question, you have to analyze like this. How much analysis is there? So which is correct, which is not. Intelligently can easily do students, which is easily can catch, you can save your time. Because while my explanation is clear, you will be automatically tomorrow, some more questions you will be able to do easily. So this is answer is B and E. This chemical question. Next, seventh question. A particle of mass 500 grams is moving on a straight line with a velocity v is equal to b into x to the power 5 by 2. Velocity. V is what? Velocity. M is how much? 500 grams. 500 grams. What is the net force during the displacement? X is equal to 0 to x is equal to 4. Students, I am telling one important thing here. You apply work done is equal to change in kinetic energy, that is always EG. Don't go by FETS because F is constant only, you can use equations of motion. So, if you use work done is equal to change in kinetic energy, this problem will become very easier. If you go by F equal to ma, A equal to again variable acceleration, if you take A equal to dv by dt or v dv by dx, if you do all these things, it will take lot of time. So whenever v function is given, so any variable force, if variable force is there, if you know velocity, somehow you know the velocity, work done is equal to change in kinetic energy to apply. That is better. So initial velocity is how much? Now I am telling at x is equal to 0. At x is equal to 0, what is the velocity here? Velocity definitely will be 0. v1 will be 0. At x is equal to 4, v2 is equal to b value they give, I think, x 4 to the power of v2. v2 is nothing but b 4 can be written as 2 square 4 power v2. So this mathematics, the empty mathematicians know 8 to the power of m and 2 to the power of n equal to 8 to the power of mn. 8 to the power of m and 2 to the power of n equal to 8 to the power of mn. So v2 you are going to get. So you are going to get 8b. What is the value of b? B value is equal to 0.25. So please see the unit, it is not staying units, but from the formula units are coming in there. So b value is how much? 0.25. 8 into 0.25. 0.25 means 1 by 4. 8 into 1 by 4. V2 value is how much? 2 meter per second. Vector is equal to what I told? Change in kinetic energy. Mass diagram is half k. Half k. Half. Vector is equal to change in kinetic energy. Vector is equal to change in kinetic energy. V2 is equal to 2 meters per second. Okay, students. Vector is equal to change in kinetic energy. Initial kinetic energy is 0. Vector is nothing but equal to half m. Half into half. V2 value is 2 square, that is 4. So vector value at x is equal to 0. Oh, x is not 3 by 2. This is 5 by 2. Sorry, this is not 3 by 2. This is 5 by 2 here. Sorry, and do this is 5 by 2. 3 by 2 is another answer. 4 to the power of 5 by 2. 4 to the power of 5 by 2. That is 2 square 4 to the power of 5 by 2. 2 to the power of 5. 2 to the power of 5. This is nothing but equal to, I will write here. V2 is nothing but 2 to the power of 32 into B. B value is nothing but equal to 0.25, 1 by 4. So V2 value is how much? 8 meters per second. I am sorry students, that is 5 by 2 is given, not 3 by 2. Therefore, it is nothing but V2 is nothing but 8 meters per second students. 8 meters per second, if you write here 8 square, it will become 64. 4 is nothing but 16. So vector answer is nothing but what? 16. Sometimes, like me, friends also get sometimes calculation confusion because I am concentrating on mainly on explanation. So I not see the power properly. X to the power of 5 by 2. Such things you don't do it. You have to go back and time will be wasted. So what we have by that time another question you cannot do. You will be in confusion. Students will be in damn difficulty in the examination hall. They have maintained cool of mind. Let us say, for suppose that question is not come. Go to the next question. Come back to that question once again after some time. Then that is a better way of doing. So don't think of about the question for 5 minutes. It is a counter examination should be done 1 minute or 2 minutes. Some questions you can take 3 to 4 minutes also. Some questions can take less than 1 minute also. Such type of problems will be there. Definitely you can be able to either NEET or JEE, particularly JEE questions are less so. So you can be able to do out of 30 questions easily 25 only or 2. 25 only or 2. The choice is also there. You can easily select 50 to 80 questions easily. As Sir told yesterday, can easily get good score. Right. Next. Students, this you see particularly. A porter lifts a heavy suitcase of mass 80 kg at the destination, lowers it down by a distance of 80 centimeters with constant velocity. A porter lifts a heavy suitcase of mass 80 kg, lifts a suitcase, and at destination, what is doing? He is lowering. After going to destination, what is doing? He is lowering the suitcase. So he is lowering the suitcase means he is bringing suitcase down. He is bringing the suitcase down like this. How much displacement he is doing? 80 centimeters. 80 centimeters he is lowering. What done by the porter? Here, how to do this problem? He is moving it, lowering with constant velocity. You apply work energy theorem. Here two works are there. Work done by porter plus work done by gravity. Work done by porter plus work done by gravity. It is nothing but equal to change in kinetic energy. What is change in kinetic energy? That will be zero because moving with constant velocity. Half mv square minus half mv square. That will be zero. This will be zero. So work done by the porter means P I am writing. Work done by gravity will be zero. So he is asking work done by the porter is how much? Work done by the porter is nothing but minus of work done by the gravity. But by lowering, gravity acting downward, displacement is also downward. So work done by gravity is positive, minus of positive. So work done by gravity mg into s, minus into plus, work done by gravity plus mgs. And work done by the porter will be negative now. Work done by the porter will be negative. But calculation you can take care of, students. Slowly you can do 80. G 9.8, the calculation is there. In this negative answers, one of the negative answers is correct. To properly calculate G 9.8 you take mass of 80 kg. Displacement 80 centimeters to be converted. S is equal to 80 centimeters, right? That should be converted to meters. That is nothing but equal to 0.8 meters. You do the calculation, you are going to get the answer. My intention is to tell you about how to take. There are two works are there. Work done by porter is there, work done by gravity is there. Total work done will be zero because moving constant velocity. Work done by porter plus work done by gravity is equal to zero. Then you get the clarity. Work done by gravity is positive. Negative of positive is negative. Work done by porter is negative. So out of these two answers, this B answer is correct. That's what is testing. Positive work. That's a simple basics also is testing. Positive work, negative work, zero work. All these things is testing. Okay, student, this is the way you are going to do. Now, time permits I do this problem, but it's a very good question actually. It's a very good question, students. For the friction idea of today, what friction force I am writing here, students? Friction force formula is mu n, always there. Moving Fk equal to Kn. Inclined plane. Inclined plane means normal reaction is mg cos theta. I told earlier chapter, the earlier chapter in the lectures, in the lectures, normal reaction inclined plane is mg cos theta. Okay, applied force is mg sin theta. So in this case, there is like this. This is the problem. So I am giving hint here, B to C. A small block slips down from point B on inclined plane AB, which is making an angle theta with the horizontal. Making an angle theta with the horizontal. BC is smooth instead. This is smooth, no friction. And the remaining section CA is rough. That is having friction. With coefficient of friction mu into. It is found that block comes to rest as it reaches the bottom. Here it comes to rest starting from rest only. Again comes to rest. When it comes to rest, B is starting, it acquires some velocity, again good roughness, the final velocity will become 0. This can be easily done by work formula. Rather than kinematics equations and all that. Work formula. BC is given as 2AC. The figure is not clear, but BC is given as 2AC. Let AC is equal to x. Then BC will become how much distance? 2x distance. BC distance is 2x distance. If AC is x, but AC is rough plane, BC is this. BC is smooth plane. BC is smooth. So work done by gravity for BC. How do you write? Only mg sin theta will be there. What is there here? On inclined plane, what will be there? This is point B. Here only mg sin theta will be there. After coming to C, here both mg sin theta and friction force both will be there here. So mg sin theta, this distance is nothing but 2x first. Mg sin theta into 2x. Work done equal force into distance. Mg sin theta into 2x. But work done by for AC plane. AC means friction force is also there. Mg is also there. Mg sin theta minus friction into distance x will be there. What is friction force? N is mg cos theta. So mg sin theta minus mu k mg cos theta or mu mg cos theta into x. Okay, total work done. This is initial work done, this is work done, total work done. Work done BC and work done the BC is how much? Mg sin theta into x, because work done is force into distance. What is force here? Only mg sin theta, because smooth plane, into 2x distance. Yes, BC means 2x. Okay, this is 2x. This is how much? X. This is A. This is rough. Rough means mg sin theta will be there, friction force also will be there. Both will be there. Mg sin theta, friction, both will be there. So this is the work done. Total work done into changing kinetic energy. Total work done. Work done by BC plus work done by AC is nothing but equal to changing kinetic energy. Delta K, that is equal to 0. Because by at B initial velocity 0, A final velocity is also 0. So by equating this, you will get the answer. Mu is equal to k tan theta is 4, k value you get 3. This is a hint given. This somewhat typical problem here given application question. So this question, so far we have done some problems, but for this question, this is somewhat application oriented question with friction. So questions will be interrelated. So this chapter interrelated with friction. So friction formula, you should know mu n. Basic formula friction is always mu n. Horizontal plane means n equal to mg. When force is applied horizontally. Inclined plane normal reaction is nothing but mg cos theta, provided theta is angle made with horizontal. So this is the thing. Next question, I have done only hint. Can easily do now by using this hint WBC plus WAC equal to changing kinetic energy by equating 0, you can easily get this. Now chain problem is also variable force. We come to this later. So we do simple problems. So two bodies have kinetic energies in the ratio 16:9. Kinetic energies in the ratio K1:K2 is nothing but equal to 16:9. They have same momentum. Both are having same momentum. Ratio of their masses. This kinetic energy. What is kinetic energy formula? P square by 2m. Kinetic energy formula is what? P square by 2m. You can take after P square also, but as well same momentum is there. Momentum is same. P is constant. Kinetic energy is inversely proportional to mass, provided momentum is constant. Momentum is same for both bodies. Kinetic energy is inversely proportional to mass. Therefore, is asked ratio of masses. K1 by K2 is nothing but equal to M2 by M1. Inversely proportional means K1 by K2 to M2 by M1. Or M1 by M2. P is constant. P constant. K1 by K2 equal to M2 by M1. That implies that M1 by M2 is nothing but equal to K2 by K1. Simple question. But reverse. K1 is K2. It is nothing but equal to 9 by 16. So masses ratio. What is the masses ratio? M1 is to M2. It is nothing but equal to 9 is to 16. There is one more answer. 16 to 9 is also there. That is wrong. But 9 is to 16 is correct. Okay, this is one question. Very simple question. This question for NEET and JEE can be asked in board level and basic level question. Right. Yes, students. 19. Momentum of the body is increased by 50%. Percentage property is very important model. Momentum of the body is increased by 50%. The percentage increase in kinetic energy in the body is how much viscosity? This is also indicated question. So kinetic energy is given by what? P square by 2m. For a given body, mass is constant. Therefore, K is proportional to P square. You like mathematics. Percentage increase in kinetic energy is asked. When percentage are asked, what how to? Initial kinetic energy K1. Initial momentum P1 you say, P1 square. Final kinetic energy K2. Final momentum is P2 square. What is K1? Initial kinetic energy. P1 is initial momentum. K2 is final kinetic energy. P2 is final momentum. K2 by K1, take ratio. Percentage number last. K2 by K1. I want percentage change in kinetic energy. K2 by K1 after this step. P2 by P1 whole square. P2 by P1 whole square. K2 by P1 is equal to P2 by P1 whole square. If P1 is 100, P2 will be 150. So 50% increase. Let us say already 50 rupees there in your pocket. You are adding 100 rupees. Or already 100 rupees is there. You are adding 50 rupees. So already 100 rupees is there. You are adding 50 rupees. It will become 150. So K2 by K1 will become K2 by K1 then will become 150. How it will become 150? If this is K1 is 100, K2 will become 150. So K2 by K1. So how it has come? My analysis is K1 is 100 and 50 more 150. 50 square 225 by 100. So K2 is 225 parts. K1 is 100 parts. How much increase in kinetic energy is there? I am writing the step here. Delta K means increase in kinetic energy by initial kinetic energy. Increase means how much? 225 100. 225 final, initial is 100. So increase is how much? 225 minus 100. Only 125 is delta. Delta K means K2 minus K1. 225 minus 100. 125 by 100. Percentage means you are multiplied with 100. So it will become 125%. So become 125%. Okay, so this is how you are going to do percentage problems. Percentage problem. One you can see once again. This is a very important word for both JEE main and NEET. Right. 29. Sorry, one problem. A spherical body of mass 2 kg starting from rest. A spherical body of mass 2 kg starting from rest. Starting from rest means U is equal to 0. Acquires kinetic energy. What is kinetic energy acquired? Kinetic energy acquired 10,000 joules. At the end of 50 seconds it took. At the end of 5 seconds. At the end of 5th second. After 5 seconds. Is asking what? Force is asking. Is asking force. How to do force? Let us assume a constant force. Force is equal to mE. Further, kinetic energy formula is what? Half mv square. Is nothing but equal to 10,000 joules. M is equal to 2 kg. You can find velocity. Half. Mass is 2. V square 10,000. This gets cancelled. V square will become 10,000. V is nothing but 80. V is nothing but V equal to plus 80. 80 whole square is nothing but equal